So guys, first things first, let's introduce you. This is our panel. We've got Jim Vajda and Chris Couch. Jim, you want to go first? And then Chris, you can go second, do a little intro.
Happy to. That's me before I grew my beard. My name's Jim Vajda. I'm the Chief Wireless Officer here at 7Signal. I guess I need a new headshot. I'm a CWNE, CCNP, some cellular stuff, currently working on the new 5G LAN materials from CWNP. That looks pretty cool. But anyway, wireless network engineer and happy to be here.
Awesome.
Yeah. Chris Couch, Senior Sales Engineer with 7Signal. Been in the industry for around 20 years. CWNA, CWTS, I think an expired ECSE design at this point, but have had that for a few different years. General wireless engineer as well as network engineer. So
Andrew said he's crowdsourcing for Jim to get a new razor.
Well, we're not happy with the beard. I like it. Jeez.
I like it. I feel like it's 50 degrees out now, guys. We got to stay warm somehow.
That's right. Thank you.
Mine was a bit longer, but I had a shaving incident, so I had to go down to nothing again.
Me too, guys. It's called dermaplaning, actually. Oh. It's a visual technique where they just get all those little micro fibers on your face. Anyways, I digress. Let's get into the good stuff. So we've got question 1. So up in the right hand corner, that's the time you got, guys. So I have a timer. We're gonna try our best to stick to it. And these are going to be all the questions that you've submitted. I already see some coming in the Q&A. So let's try our best to stick to this, guys. So question number 1 submitted by our buddy Scott. This is for Jim Vajda. How do you guys design for a highly reflective environment?
Well, thanks, Scott. I like the question. I think you probably have a better answer than any of us because Scott, if you don't know Scott, he does Wi-Fi in factories and industrial settings, probably the highest reflective environments that Wi-Fi is deployed into. But I will say in general, you want to keep your transmit power low, in order to reduce the amount of reflections that are occurring. Using directional antennas, again, to focus the RF away from reflective materials and just towards the area where you need coverage. And then, AP placement is a big thing too, right? You don't want to place your APs if you can, right? You want to avoid placing them near those areas where there's going to be a lot of reflectivity. The closer they are, the higher the power is around those areas, and the worse the situation gets. So those are some kind of design ideas. The other thing, using clients and APs with multiple spatial streams, multiple transmit and receive chains can help. Not only because those can increase the throughput, but also because if one path has failed, another one may work, and you have some redundancy there. Even if you have APs with 4 spatial streams and you have clients, you don't have clients with 4 spatial streams. When that AP is receiving, it's going to receive on all 4 radio chains and combine the signal it gets from all 4 to hopefully overcome some of the challenges that reflectivity poses. That's my answer. Chris, anything you want to add to that?
Yeah, kind of in the design aspect, taking into consideration how you're placing those antennas, not only using directional, but, you can use a showerhead approach coming straight down from the ceiling if you have the ability, can help alleviate some of that. Staying away from, omnis can cause some problems there because just of the nature of it with so much reflectivity. But yeah, I think you covered most of it.
Sweet. You guys were crushing it on time. So good for you. We have 2 minutes left.
Excellent.
All right. Awesome. Well, let's move on to the next question. We've got question number 2 here, which is submitted by Bruce Hunt. So we do have some context before we get into the actual question itself. So Bruce works for a manufacturing company and has to make tweaks to improve performance in real time as the network is in use by utilizing tools provided by the platform that they're using, Aruba. Although I prefer to go on site to pick AP mounting locations, I can get pretty close by judicious use of digital photos and performing only a predictive survey at a cost that is much cheaper than traveling to the site itself. So here's the question. Wireless is, of course, extremely dynamic, and costs are important to all companies. Since Bruce has the ability to tweak after the fact, and given that an on-site survey is a point in time, and that point in time is in the past, what is your opinion on that approach? And this is for both of y'all.
Yeah, I think Chris and I just had the longest discussion about this question when we prepared for this. I think, it's good, Bruce, that you recognize that if you're going predictive only, then that creates additional operational work after the design to have to tweak and maintain and keep a closer eye on it. But I'm not a big fan of this approach. I think you need to have some level of on-site validation. I mean, you can do predictive only design if you're really comfortable with, the area, and you feel the construction materials and you've had success within your company in the past doing it. I think that's okay. But for the validation, I think you need to go on site, not just to perform a site survey measuring the RF, but also just to do the simple things like see, did the installers place that AP where I told them to place it, or did they actually mix them up? And now actually the APs I've set up in Prime or Airwave or whatever it is are actually not in the right spots. I need to flip them around and fix them. Those kind of problems you can't really overcome without going on site. So that's my take on it. Anything to add, Chris?
No, yeah, you covered exactly. That's I can't remember how many designs I've done where installers just swap a box or label an access point, and you catch that in a validation where you're walking around, next thing you know, you're seeing a MAC address you're not expecting in an area, or you catch a radio that's not working. You may see it as online in the controller, or clients aren't attaching to it, something else is awry in that area, or just if you are using external antenna access points that they're actually hooked up correctly. They actually have the leads in the right spots, because some antennas do require that. So I've seen them, some of them 2 of the 4 are connected. They may have the back in the olden days when you had split radios with 2.4 and 5 gigahertz, they had the wrong antenna leads hooked up to them. So yeah, getting that visualization, utilizing digital photos is fantastic. Back when I was doing designs all the time, I would take 4 and 5 pictures of every access point from different angles, so that I could prove that connections were right. And if you have that level of installer that's going to do that for you, that can certainly help out. But making sure that the coverage you're expecting, and then also gives you the opportunity to it is a point in time, but you can also see how much has changed, and then also be able to tweak your in the Aruba case, the ARM profiles. If you're using ARM for channel and power, make sure those are lining up with what you're expecting. Make sure that your cell sizes are equaled out. And then if they did make a huge change, then you have that on-site knowledge to be able to really make those additional changes to the design after the fact, and have them move access points if needed.
Yeah, and I have personally dealt with designs where the APs weren't installed exactly where I wanted them to go. Maybe one was just around the corner in a hallway, and that actually had a significant effect on the RF design. And just walking the site and saying, is that AP there that's supposed to be there? And is it the AP I expect to be there is really critical, beyond validating the coverage of each cell. So, and also, like you mentioned, if you're going to be tweaking after the fact to kind of clean it up now that it's installed, you really have to know your APs are where you think they are. Otherwise, you're tweaking, you're making configuration changes against the wrong APs. So one other point I'll add here is some systems and I can speak from experience with Cisco. Cisco will create its neighbor list table for each AP, which 802.11k uses for neighbor reports. And it will actually, the controller's will reach out to Prime, or I think it does this with DNA Center too, and say, okay, here's this AP and clients are going to request a neighbor list from it. Tell me what APs are on the same floor as this AP, right? Because we don't want to tell a roaming client that, hey, roam to this AP on a different floor, even if the signal strength might be okay. So that's another reason why you need to have really good data in your NMS, because sometimes that's used for operational things like 802.11k neighbor reports.
And Bruce has put some stuff in the chat too. So it looks like he's got some pretty good installers that are taking a bunch of photos while they're on lifts. And he's also flashing APs as the installers are actually putting them up, which is a great way to validate, that way you know exactly which one is which. So yeah, you're doing the right things. I mean, it's always back to that, it depends, but it's always nice to validate and verify that everything is working. Even if it's not yourself going on site, to have somebody go through and do a validation where they're simply walking and collecting data, it doesn't have to be yourself doing it. You can have another tiered engineer to do it as well.
I always see different things too. I think we're at time, but Heather's
I'll say, like wrapping it up.
I could have really good floor plans, and then I go on site and it's like, oh, there's no ceiling here, it's open to the next floor, or there's this massive rack, or the furniture's here. Mm-hmm. There's just stuff that you learn from going on site that it's hard to get otherwise. So leave it at that.
Awesome. Cool. All right. Question number 3, also submitted by Bruce. Bruce got lots of questions for us and I love it. So what do you think of using the 635s in the office areas, not a shop floor office area, and using 515, 514s in the shop warehouse areas? Do you see the mixture as a concern as long as we aren't mixing 635s with 514s in one area? Lots of numbers in that, as I say it out loud. Chris, this is for you.
Yeah, I mean, I think you're on the right track, with the 635s in office areas, obviously, carpeted spaces with, with the 6E access points, not having external antennas, separating those out from your warehouse areas is a great way to do it, as long as you're not taking those 635s and sticking them in there with the 500 series. You're really going to get a better experience. But, I think the question's more around having internal and external antenna access points in the same area. I don't think that's so much an issue. Obviously, you just have to be able to design your cells to meet the antenna types, because, I mean, an external antenna and internal antenna access point are the same. You can just change the direction in which they point. So as long as you're basing your designs off of the coverage area of your 515s, and then when you install your 514s and you go to that external antenna selection, you know your cell edges, your cell sizes, I don't see an issue to with intermixing them, just as long as you design to the capability of the access point and the antenna you're working with. There's many benefits to doing that, not only in just cost, because you have just a single access point and you don't have to worry about purchasing another antenna and different mounting equipment, all kinds of other stuff. But sometimes an omnidirectional antenna will work just fine, and you don't need a high gain or directional in certain areas. So I think that's really let me see here. It was more about 6 gigahertz capable mix. Oh yeah, no, I would completely, okay. So if that's the way Bruce you're looking at is intermixing 6 gigahertz with 5 and 2.4, then I would say completely separate them. I don't think you're going to get an advantage intermixing 6 gigahertz where you're transitioning between radios in a warehouse area or even in an office area. You're going to get much advantage out of that. And I would I don't like really mixing series together. I would say stick with one, because not only from a life cycle perspective, how long that AP is going to last, you're going to know the software version they're on. You're not going to have to worry about replacing them individually, and you can kind of build out an entire coverage pattern based on a capability of an access point rather than intermixing 2 different ones. So if that's the case, I would say stick with a series for one area, segregate the other section out, stick with 600 in the office, 500s in the warehouse, because you can't really have a 600. There's no 600 externals. So there's no external antenna APs that are running 6E. So I don't know really what you get advantage out of that. Besides the devices, I don't know if you would even have any 6E devices out there yet, but I think putting those in there would just kind of cause confusion with the devices anyways. So I would separate them.
Yeah, Bruce, let us know about your 6 gigahertz capable clients too. But I would just assume they're more likely to be found in the office areas, with Intel AX 210 and 211 wireless adapters being probably the most common 6 gigahertz client now. You'll see those in the office area, and you might have again, tell us, but you might have higher density of users in the office area where having the extra capacity from 6 gigahertz and those 635s is going to be a bigger benefit. So,
Yermon,
good question.
Yermon, just to clarify a little bit. So 635, the 515 and 514 are all Aruba access points. The 635 is the 6E access point internal. The 515 is an internal access point from Aruba, and the 514 is an external antenna access point from Aruba.
Awesome. All right. And thank you guys for keeping our chat so full. This is really great. And we already have so many Q&A questions in the panel. So awesome. Let's keep rolling. So we've got question number 4 submitted by Mike. This is for Jim. So can you replace an existing 5 gigahertz only network with a 5 or 6 gigahertz network while replacing APs 1 for 1?
Literally, yes, you can. Is it advisable? That's a longer answer. I would suggest against doing this, and the reason for that is, although usually omnidirectional APs, internal omnidirectional APs, sort of generation to generation, have pretty similar coverage patterns, and you can work with the transmit power within the AP itself to overcome any significant differences. But that's just when you're doing, like for like in terms of, 2.4 and 5 gigahertz coverage between generations. What we've seen with 6 gigahertz is that while the AP's coverage cell is somewhere between 2 and 5 dB below typically what you'd get from 5 gigahertz. And some people have concluded, well, that's not a very big deal. The 6 gigahertz clients are going to be using 80 megahertz channels. And so, the bit rate's going to be pretty high, even though the MCS may be slightly lower. So it's just a wash. But the problem is with 6 gigahertz is that the clients are limited here in the US. And let us know, what the rules are around the world, by the way, if anybody has insight into that. But here in the US, a 6 gigahertz client can only transmit at a maximum of 6 dB below the current transmit power of the AP. And that's because clients aren't in fixed locations. Some might be outdoors, and when there's a lot of clients, they create a lot of RF energy in dense areas, a lot more than the APs themselves will create. So that's just a protection mechanism, or shouldn't call it that. That has a specific meaning, but that protects incumbents from interference from Wi-Fi. So the result is, we're probably close to 3 minutes. The result is the uplink performance is a lot poorer for 6 gigahertz clients than a comparable 5 gigahertz clients, because usually clients blast away at full power all the time, and certainly in 5 gigahertz they do. Often that's higher transmit power than the AP itself is using. Certainly in enterprise networks, that's common. Now you'll have clients transmitting 6 dB below where the AP is currently transmitting, and that really can make the uplink performance suffer. So that's why you need to redesign, why I would recommend that, and take that uplink performance into account with a higher density of design for 6 gigahertz to perform well. And thank you, Anders. He says in the EU, it's the same TX power on both AP and client. So they don't have the 1200 megahertz we have, but they do have better transmit power rules. So interesting.
Great. Moving on to question number 5. This is, I'm sorry if I mispronounced, Matthias. Matthias,
maybe.
Feel free to shame us in the chat. This is for Chris. Question is it really wise to use channel width of 320 megahertz in Wi-Fi 6E?
Yeah, so that's more of a Wi-Fi 7 kind of requirement. In the current Wi-Fi 6E standards, it's not supported. I don't know if there's any clients out there that support it, but really it comes down to channel usage. As Stephen just posted in the UK, they have 500 megahertz, and Anders put in there 500 megahertz of available spectrum. If you're using 320 megahertz wide channel, you have one channel. You don't have any overlap. So in your house with no neighbors, maybe when it's supported and the clients are supported and the access points are there to support it, because currently, even if with the additional bandwidth, there's features in Wi-Fi 6 that aren't even out there yet. And I think Jim and I talked about preamble puncturing and some other things that aren't even supported yet, really, or even out there. I mean, it's in the standard, but it's not actually being supported. So until that stuff gets out there, I don't know that it's even in the US. I think you maybe have 3. I would probably single channel architecture. I like it. I don't. I would probably stay away from this as best you can, depending on where you are. Unless, like I said, you're running a single access point in your house and no one else is around you and you're a good wireless steward, maybe. But outside of that, I'd definitely stay away from it.
It's counterproductive in my mind. In order to use that 320 megahertz of spectrum, you have to do CCA across all of it and make sure there's nothing going on there. So you're going to run into channel access issues, but also there's no use case for it. Why do you need whatever it is, 10 gigabits per second, 40 gigabits per second over your Wi-Fi link?
Yeah.
If anybody has a good answer, we'd love to hear it.
I could recommend Ethernet if that's what you need.
Yeah.
All of our attendees from the Stop Saying Data Rate webinar are slamming you a little bit.
Yeah.
Oh, that's too funny.
I did slam at SCA last week.
Yeah.
Awesome. All right. Question number 6. This is for Jim, submitted by John. Under what circumstances is RTS CTS invoked? Is it initiated from the client or infrastructure, or either? If I see RTS CTS frames, does it always mean the airtime is congested?
So this could be a webinar all on its own, but I'm going to do my best to answer in maybe a little bit over 3 minutes. But so I'll go backwards. I'll go backwards because it's the end of it is easier. If I see RTS CTS frames, does it always mean the airtime is congested? No. I would suggest most of the time RTS CTS is in use. Airtime is the channel, we'll say, is not congested, although it could be. Is it initiated from the client or AP? It's either one. Sometimes the client is doing it because it's required by the AP, but they cannot, both of them can decide on their own when to use it. And then the long answer, under what circumstances is it invoked? So there's a number of circumstances, and it's kind of changed over the years. The first purpose of RTS CTS was to address hidden nodes. Anders got that one right. So if a client on a, if you have 2 distant clients that can't hear each other and they're both talking to the same AP, they will happily transmit over top of each other, and then the AP receives both signals at the same time. They corrupt, there's interference and corruption, but the clients don't understand why that's happening because they don't hear each other. So they're not backing off and each other is transmitting. So that's the hidden node problem. And way back in the day, you could go onto into your clients and turn on RTS-CTS to prevent that from being a problem. So what it would do is, say we had the same scenario. Well, one of the clients would send a request to send frame to the AP. The AP would respond with a clear to send frame, which all of the clients hear, and sets the nav timer. So all of the clients are backing off while that original client gets to transmit its frame. So we address the hidden node problem. Then RTS-CTS, this is where it kind of got a bad rap in my mind. It started being used as a protection mechanism for backwards compatibility in 802.11g and 802.11n. So those are generations of Wi-Fi that operate in 2.4 gigahertz along with 802.11b. And in order to gain channel access, they had to use RTS-CTS to set the nav timer on those 802.11b clients. And they had to send it in, 1 megabits per second with that old 802.11b preamble. So you lost a significant amount of airtime doing that. And that's when it became kind of a design consideration to disable that protection mechanism. Just to, even if 802.11b clients suffered, you took the trade-off and won back some airtime. I think today, we can use OFDM and higher MCS rates for our or not MCS rates, but the OFDM rates for our control traffic, and use the much shorter OFDM preamble for those. And so the airtime consumption in modern networks from RTS-CTS is much smaller, like a quarter of what it used to be. And so there are new circumstances where you see RTS-CTS in use. A client or an AP that needs to do a long period of frame aggregation, AMPDU, will start that with an RTS-CTS exchange so it can reserve a transmit opportunity, a really long one. And everybody knows, hey, for this long period, just this one station gets to transmit. But the other, probably even more common circumstance now is with wide channel access. In order to access the channel and gain channel access at any channel width wider than 20 megahertz, we have to first do RTS-CTS. So if you've got your AP channel width set on anything besides 20 megahertz, you'll see RTS-CTS all the time, and that's normal. So we can reserve all the subchannels and set the nav of any OBSS stations that happen to be out there. Last note: there's a really cool feature in 802.11ax called duration-based RTS-CTS, where you can set a threshold. The AP sets a threshold in time, in duration, that triggers the requirement for RTS-CTS. Previously, we used bits or bytes. If you had so much data to transmit, that was the threshold. But that doesn't really make sense, because it doesn't, if you're using a 1024 QAM rate versus a BPSK rate, the airtime consumption is wildly different for the same amount of data. So it's really about airtime, and that's a neat feature in 802.11ax. So went a little bit past 3 minutes, didn't I, Heather?
Just a skosh. That's okay. Now we're getting into the long boys. So these are some multi-part questions. So we'll do our best, and however you guys see fit to tackle these, if you want me to read all of them or one at a time, just let me know. But this is a multi-part question from Jan for Chris first. This is question 7. And there are multiple parts to it. So let's start with this first part here. So where should I place APs in floor plan, and how many? Is there an automated tool or rule of thumb?
Oh, well, there's a lot of depends in this question. It's very subjective based on the requirements of the design. So if you have floor plans, or first, you have to start with the design requirements. what are you designing to? That's going to dictate cell size. That's going to dictate overlap, AP placement. Is it a location design? Is it a voice design? Is it just coverage? Or what are you trying to accomplish out of this? Is really going to put where you're going to start placing your access points and how you build them out. So you can go anywhere from crazy small of 1,000 square foot an access point to 2 or 3, 4,000 square foot an access point, if you're depending on what your requirements are. So that's really kind of give you where you're going to start your design at. From there, in your placement, you have to look at what you're trying to accomplish. Are you trying to keep your cell sizes down? Then you keep them out of hallways, you put them in rooms, you provide loss values in there to be able to reduce that cell size and to operate at a lower power level, or to operate at a higher power level and use your loss values to keep the cell at a smaller size. So understanding the architecture, understanding the building, where are your stairwells at, where are your elevators, what's the conference room, high density areas, those types of things all come to play of where you're going to actually place those. And then the design requirements are going to give you really the size and placement of where your access points are going to go. Can you go back one slide real quick? I just want to make sure I covered all of that. So the automated, there's plenty of programs out there that will throw dots on a map, but without taking the proper measurements and understanding what your loss values are in a building, what are your wall types made out of, actually putting an access point up and then going away from the other side of it and looking at what you're getting on your reading from the other side of that wall, understanding the architecture of the building. Was it built in the 2000s? Was it built in the 1800s? All those construction materials come into play. So if you have good information going in, then you're going to have good information coming out. But if it's garbage in, it's garbage out. So if you put a floor plan in there with nothing else besides requirements, it'll put 1,000 APs on a map and not really give you anything good. You really have to provide excellent data coming into this to use it as a kind of an automated tool. I'm not a big fan of automated placement because you need to understand what your customer or yourself or your environment's really trying to accomplish. By letting somebody else do it, it really doesn't give you that much. You don't really gain anything out of doing it automatically without understanding what your requirements are.
Yeah, those systems are really garbage in, garbage out, and there's only so much high quality data you can give to them. So
yeah, absolutely. Yeah. Second part of this. So I've dealt with this quite a bit in my past, stairwells, elevators, corridors, that sort of thing. Learn your local fire code. Talk to whoever's doing the inspections, understand what the rules are, and see if you're even allowed to put stuff in those areas. That is a very touchy subject because, in Ohio, I don't think you can put anything except for what is necessary. You can't put conduit in there unless it's, health, life, safety with lighting, fire exit signs, that sort of stuff. There's a lot of restrictions you have to worry about. So if you're designing for that, if you need to put one on the outside of that stair tower of what they call it, or stairwell, whatever it's called in your design, you potentially could get some bleed through from putting an access point near the outside of it. But just take that in consideration in your design, that, we're having an access point right next to this that's going to be blocked on the other side of this because it's, insulated, fireproof walls and everything else. You're going to get some coverage. But if you need it for health, life, safety, or if there's a reason that you're doing VoIP for, a hospital system or something along those lines, make sure you talk to your local fire inspectors, make sure you talk to the architects and the building designers to really make sure that that's something you can get away with. And I would say get away with it. It's going to be allowed by them and by code. Same thing with elevator shafts. Talk to them the same way. They make permits and things to do that you can mount on the cars with, cable that fits the reels and whatnot. So there's a lot of things to take in consideration, but especially for coverage and roaming, I think that all kind of falls in the same thing.
Awesome.
Yeah. I agree with Randy. Fireproof walls are a headache. Absolutely.
Oh man.
Nothing worse than an MRI room though. So lead line walls, that's even better. Okay. So
Part 3.
Campus buildings with open space courtyards. Should I place outdoor APs? Will they call CCI with the indoor access points? Yes and yes. So depending on what you're doing and your power levels, they will bleed back through the walls. You can cause co-channel interference with that. And this all comes back to design, understanding your building materials. This comes to architecture, where you're placing these access points. Are you doing omnidirectional APs? Are you doing directionals? What are you trying to cover in the size? That really comes into play for the outdoor areas, but outdoor APs are rated for the outdoor by the FCC. There's a lot more control. There was in the past where you couldn't use indoor access points outdoor, or run indoor access points indoor and put antennas outside. That was kind of a no-no a while ago. But I think you can get away as long as you stay within the power levels. Just make sure you check with your jurisdictions and it is allowable. Same thing with the fire stuff. You make penetrations in walls, you have to make sure that stuff's all sealed, waterproofed in the right containers and everything else. But co-channel interference, yeah, you can, especially if you're running them too hot. And I've seen a lot of outdoor access points just get into a default profile where they're just getting, it's 30 and -1 if you're on a Cisco controller, or, it's power levels 1 through 8, and it's just hammering away. So keep an eye on that. Same thing with the channel plans and the power levels. Keep it in check and you should be good to go.
Yeah. And I think, using like patch antennas facing away from the building, on the edge of the on the exterior of the building facing out is a good way to help, address CCI and also direct the signal where it needs to go. Yeah.
I've seen that come into play a couple different times in courtyards. Like when you actually have a bunch of buildings, like in universities and schools, where they've got a bunch of buildings around and you're trying to cover that inner area as they walk through in between. It's just knowing what you're pointing at and then adjusting to cover for it.
Yeah, I've done that myself. And one of the benefits is if you can penetrate the exterior wall, then you can use an indoor AP inside, right? Mm-hmm. Inside, protected from the weather and not requiring, a more expensive outdoor rated AP, and just run the antenna lead through that wall penetration. So
yes, correct, Anders. Yeah, Wi-Fi 6E is not allowed outdoors. There are no outdoor 6E access points as of yet. I think Cisco has one, maybe.
Yeah, the hardware's the AP vendors are already selling the hardware. I think Cisco and Extreme have APs on the market for outdoor installations. They will sell you, but you can't use that 6 gigahertz radio yet until the regulators approve it and the software is updated and so on and so forth. So
correct. Yeah. Don't get yourself in trouble.
Buyer beware. Yeah.
Yes.
I'm reeling you in. We're about at time for this question, but I do want to make sure we finish this up. So this is the last question for Jan. So if you want to just do it in like 30, 60 seconds. It's about band SSID. Should I crank 2.4 gigahertz power up to make up for insufficient coverage in critical areas?
If you have a critical area, add another access point designed to the requirements. Don't try to cover with power. I don't foresee that. I think you introduce too many other issues if you try to resolve with power, because you end up flooding out other areas that are probably not being considered. So I would not do that, because I'll just leave it at that. I wouldn't recommend it. If you have the ability to add another access point to cover for it, go that route rather than solving it with power.
Yeah, and if you crank up 2.4 gigahertz specifically on a dual band SSID, all those, those clients that I'm trying to find a family-friendly word to describe them, but those bad behaving clients will just roam to 2.4 and stay there because the signal's so loud. We don't want that. So
absolutely.
Yep.
Thanks for
Fix
that.
the design.
Yep.
All right, Jim. It's time for your 7 minutes with 7 signal here. So question 8, this is from Forrest, one of our regulars. So this is another multi-parter. So we're going to start with this. Where can I see a list of all the data that an AP is putting out when it transmits beacons, not while it's communicating with any STAs, rather while it's just sitting up there advertising itself? Is any of that transmission user selectable other than beacon frequency?
Yes. So the best way to see it in my book is just to do a packet capture on the channel and look at that beacon frame, and you'll see all the information elements, which especially with 802.11ax APs and so forth, there's so much complexity, and a lot of that is not exposed anywhere in the GUI or even the CLI for an AP's configuration. So do a PCAP, and that'll show you absolutely everything in the beacon. You can, if you want, set up an AP in the lab with an SSID nobody knows, so you can get it while it's not communicating with any stations, if that's what you need to see. But that's what I like to do. That's where you can see things like the duration-based TX out threshold. It's an 802.11ax.
Now, I have to throw this in there that you can do a packet capture from our Sapphire Eye.
Absolutely. Yep.
Awesome. All right. This is a follow-up part 2 of this. So when a device hears the beacon transmission, is it correct when it reports the RSSI in that it's actually determining the RMS value of that complex waveform, similar to a wire with a complex waveform where the power of the waveform, lots of waveform, can be determined with an RMS meter? Or when an AP is transmitting, would the measure be, I'm not sure what they're trying to say, or when an AP is transmitting, would it be measuring RSSI, although maybe the transmit time is too short to make a difference? How are the antenna radiation diagrams really used?
Okay, so a couple of things kind of mixed together. I'll take the first thing about RSSI. It's actually quite a rabbit hole, and I'm going to punt a little bit. I just dropped a link to a really good talk from WLPC 2018 called RSSI Revealed, and it goes down that rabbit hole. Unfortunately, in Wi-Fi, RSSI is not measured in any standardized way. If you read the standard, you won't find a clear definition of it and a clear way that hardware should be calibrated. All it really says is that it's a measure of the received power of a 802.11 signal, and that it should be used relatively in the sense to compare previous signals to future signals. So the chipset vendors that make Wi-Fi chipsets have to fill in the rest, and they do it their own way. It's proprietary. And maybe if you're lucky, you work for an AP vendor that has a cozy relationship with a chipset vendor, and they'll explain where their RSSI value comes from. But even with that knowledge, there's a huge divergence in RSSI values, even within the same make and model of chipsets. So unfortunately, there's no good answer. It's not a super reliable metric, and that's actually why at 7Signal we've sort of transitioned into looking at MCS rates rather than putting a lot of weight on RSSI. Is it measured when the AP is transmitting? Yes. And no, it doesn't. It's usually, I think, measured during the preamble, so you don't need to worry about how long the transmission is. And yeah, unfortunately, it's not as simple as how we can measure a wave on a piece of wire with an RMS meter. I don't know if chipset vendors are using RMS or not. I'm going to guess not. How are antenna radiation diagrams really used? For design, right? We want to find the antenna radiation pattern that matches the use case and needs of the area we're deploying that antenna. And we use those to understand the coverage pattern. That's the short answer.
All right. And then this is kind of a situational question. This is our last of the ones that we've collected. And I'd love to get to like maybe 1 or 2 of the ones that were submitting Q&A because there's so many. But can you recall a situation where a design does something different because of the radiation pattern beyond the obvious major differences like planar and omni? From transmitter to receiver, why is signal at receiver degraded? This is the most I've ever talked in a webinar. Can you tell?
You're doing great.
The water is not in the way. Why would the waves above the water be, quote, pulled down?
So that last part is really interesting. I'll start with the first part about designing differently because of the radiation pattern. And I think the what's the inference here is that the sort of antenna is being dictated as part of the design. That's not ideal, right? We want to be able to select the appropriate antennas as part of the design process. As the wireless designers, we should have the control over that. But maybe that's not possible because of some budget constraint or something like that, in which case, a customer might say, hey, we're just going to use internal omnidirectional APs. And it's up to us to, one, let them know if it's going to work or not, if it's even possible, right? Never just accept constraints like that, because if they're setting you up for failure, they'll happily, blame you when it goes wrong. So if you think that they've selected an antenna and are forcing it on you that isn't going to be able to deliver the performance they need, it's up to you to say, no, this won't work.
Absolutely.
This is just, we have to do something else. Let's get creative and say, no. But, sometimes, customers aren't interested in doing external antennas where we might want to, and then can we make it work with internal omnis? Yeah, sometimes we can, and so that has a large change on the design. Anything you wanted to add there, Chris?
Yeah, no, I think you're absolutely correct. And when the design fails, it always comes back to either the project sponsor or the person designing it. So this is one situation where I have no problem saying no or putting your foot down, to find additional funds to make it right, because all you're going to do is make a wireless network that doesn't fit the needs of the design, and therefore is going to cause production loss in the future. So, or introduce other issues. So it's not worth making a bad design to begin with. Make it right the first time if you can, and then your life will be that much better after the fact.
Mm-hmm. Yeah, if you're given a set of requirements that prevent the network from performing the way it needs to, then you need to put your foot down and say, look, I'm the wireless expert here. This isn't going to work. Don't do this. Mm-hmm. Let's find another way.
Yep.
So the second part of this is an interesting question. For a transmitter to receiver, why is the signal at receiver degraded when passing over water? Water's not in the way. Why would the waves above the water be pulled down? That's a really interesting question. It's really something unique to the 2.4 gigahertz band, where 2.4 gigahertz actually is a resonant frequency for water molecules. So if you have a signal that's encountering water in the 2.4 gigahertz band, the water's just going to absorb it all. In fact, that's exactly what happens in your microwave oven. It turns on 1,000 watts or so of 2.4 gigahertz RF energy, and all the water in the food, the water molecules absorb that energy, and it gets converted into heat. So it's not so much that the waves are getting pulled down, but it's usually in particularly indoors, there's some reflectivity with most materials, and you'll get multipath, and signals will bounce around and continue down a corridor or through the room. Whereas, you don't get that effect in, say, a room with a big indoor pool. A lot of that 2.4 gigahertz signal will get just absorbed, as it bounces around, because it's not just going horizontally in a straight line, especially indoors. It's really just bouncing around a lot, and eventually it's going to hit that water and get absorbed. So interesting phenomenon there.
Yeah, I'll kind of giggle a little bit with Kit here, but people have that influence as well. We do have quite a bit of water in us, so we do absorb quite a bit of energy as well. But I've seen this specifically in a lot of warehouse designs where there's a lot of fluid, especially in the medical field. And some of the facilities I've designed with IV bags and stuff like that, when they're in giant pallets full of stuff, it will tear a design up. And the next thing you know, they shift it to the other side of the warehouse, and now I've got a big hole or overpowered areas where I'm trying to compensate. So standard cell sizes usually help out with that.
Yeah, next time I'm feeling too important, I'm just going to remind myself that I'm just a fleshy bag of salt water. So thank you for that, Kit.
Oh, that's awesome.
You just got to remind yourself sometimes. All right, guys. Well, that is all we have for the submitted questions. We have like 6 minutes left, and so many of you are wonderful enough to submit some Q&A. So you guys, it's your turn. Pick one question each. You have 60 seconds. Jim, you're first. There's some obvious clear ones.
Yeah, I'm going through some of these. So Daniel said something about potential of a 320 megahertz outdoor point-to-point link. What are your thoughts on that, Jim? That's, you still got to get clear air for the whole thing. I don't know
Yeah, I don't like that. One of the challenges, one of the purposes of a point-to-point link often is, as like a backhaul link. So that's going to be a busy link, and it's going to need pretty reliable channel access. I think with 320 megahertz, you've got 16 20 megahertz sub channels, all of which have to have a clear CCA in order to be able to transmit. And maybe preamble puncturing will come to the rescue with Wi-Fi 7 and help out with that problem. But I'm hearing from people that they're skeptical about how well that's going to work in the real world. I don't know either way. We'll have to wait and see. But if the goal is to get multi-gigabit backhaul, look to 60 gigahertz. Look to 802.11ay, where there's far less co-channel interference or channel access challenges at all, because the signal degrades so fast. That's probably a better way to accomplish that at extremely high throughput needs.
Yeah.
Chris, what do you think? You got one more?
There's some that are just, I don't think I could answer in 60 seconds. I think, the MGig question is definitely always a fun one. That was a great presentation by Pete at last year's WLPC.
I got one.
Go for it.
I got one from Vajda. And she asks, what's the best book you've read so far in wireless? And for me, it's actually this one, which I've used to look up some of my answers today. A little glare on there. Let's see if we can get it to focus.
Yes.
It's Next Generation Wireless LANs. It's just updated through 802.11ac, but it's extremely technical. The authors were, focusing on me again. The authors were some of the original or have contributed directly to the 802.11 protocol, and it's excellent. I wish they would come out with a similar book for 802.11ax, maybe one day. It's usually kind of expensive. It's like textbook pricing, but for me, definitely worth it.
Awesome. Chris, what's your favorite book? Let's end on that note. That's a fun way to end.
I don't even know. I've got a pile of them around here. I'm going through all the rest of my CWNP stuff, so I will list all of those as my favorite books right now.
Vajda says she already bought that book.
Oh, there
let
you
me
go.
see if I might have something else. Here's one. Okay, so this just came out this year, and it's
yes.
Wireless Security Architecture from Jennifer Manila, who is focuses on wireless security. And there's a lot of where next generation wireless lands is protocol and theory and super nerdy and sometimes disconnected from reality. This will help you get your job done if you're doing enterprise Wi-Fi. So very, very good book here too.